Hi everybody, I'm Tanmay and today I will walk you through something that sounds futuristic but is happening right now. Liquid neural networks. Now, when we hear about AI, most of us think about massive models like ChatGPT and Claude. They are powerful but they are rigid. Once trained, they do not really change unless you retrain them. Liquid neural networks flip this idea on its head. They're designed to adapt on the fly, and just like how we humans adjust when something unexpected happens, liquid neural networks do the same but in their own particular quirky way.
Problem with traditional AI. Traditional neural networks are stacks of weights trained on large datasets. Once training is done, the behavior is mostly fixed. They excel at repeating learned patterns but struggle when faced with new, unpredictable situations. This rigidity limits their usefulness in real world where conditions are always changing. Liquid neural networks, on the other hand, change the game by treating each neuron as a differential equation. This means the neuron state evolves over time based on its surroundings and its input from the previous neuron. Think of it as a living system constantly reshaping itself instead of being frozen after training. This allows the network to adapt continuously in real time scenarios. Now, why does this matter? The real world is an unpredictable road. Markets, environments, and situations keep changing constantly. For example, autonomous cars. Liquid neural networks handle roads they have never seen before or have never been trained on. When it comes to drones or robots, they adapt and overcome obstacles dynamically on the fly. While it comes to wearable devices like smartwatches and rings, they run a light model with real time learning, which helps them to understand the user's habits and give a better output. Here's a simple experiment I ran. Both a standard RNN and an LLN were trained on a sine wave. Initially, both predicted the pattern correctly. Then I changed the wave's frequency to simulate an unexpected scenario. The RNN drifted and struggled to follow the new patterns, while the LLN adapted immediately and stayed accurate, even when far fewer parameters were provided. This shows the strength of the LLN in real time and its adaptability and efficiency. The comparison table shows how the LLN is better compared to the RNN in various factors. To sum up the presentation, here are some key points about LLNs. Adaptive, continuously adjust to new data. LLNs are effective. Smaller models and less computing power is required to solve the same problem. LLNs are also resilient, that means they handle unknown areas and unknown situations better than traditional AI ever could. These qualities are why LLNs are getting attention in real world AI applications. Now let's talk about LLNs' future and their impact on the real world. LLNs are more than just our normal research experiments. They are already shaping AI in real world. From drones navigating challenging environments to robots in unpredictable spaces, they can handle situations traditional AI cannot. This represents a shift in AI design. Instead of endlessly scaling the models, we are moving towards smarter, adaptive, energy effective AI solutions. The researchers at MIT have their own spin on LLMs called Liquid AI. It is a developing liquid foundation model which shows promising future for AI's evolution. Now, here's a thought-provoking question to end the presentation. If AI can evolve in real time, how might it change the way we interact with everyday technology?